Okay, so today we're going to do 1.2 and 1.3. Okay, because 1.2 we're just going to do the whole thing together, right? So if you have your book open, you can follow along. We're basically just going to work through all of the Explorer, and we're going to do every question together. Okay, that's why you want to have a piece of paper out so you can write them down. And then we're going to work through 1.3. Tomorrow we'll do 1.4, Monday review, Tuesday test. Okay, on all of chapter 1. Now, one of the things with this stuff is that the answer to the question is just going to end up being a box with a couple of circles and a bunch of numbers in it, right? What's more important is the order in which we write the numbers, right? I mean, if all you're doing is looking at the final answer, so that's all you're going to have written down is the final answer, it's not going to mean a whole lot if you didn't know how it happened, right? So that's why if you're not paying attention and then you look up, you're not going to know how to do these questions.
Miss Britton, please call the main office. Miss Britton.
Give her some time. And the other thing is then, of course, that you can play back through this. So if you're confused, if you're looking at something, it's just, yeah, okay, there's a whole bunch of circles and numbers and that. How did that come about? That's when you come back to this and take a look. It's all right, how did we fill this in? Right. The other thing you might want to do is, as you're writing numbers in or something like that, you might want to put like a little 1 with a circle around it. Say, this is the first number we put in. And put a little 2, little circle 2 beside the other thing. Say, so we did this, then we put this number in, and then we did this. Just so you have an idea what order things happen in, because it is kind of important in this stuff. Okay, explore the math. In an Alberta school, there are 65 grade 12 students. Of these students, 23 play volleyball and 26 play basketball. There are 31 students who do not play either sport. The following Venn diagram represents the sets of students. And you'll notice, best Venn diagram shirt ever. The intersection between the two things here, right? And that's what we're doing here, right? There's an intersection between these circles. So what do we lead off with? What's the first number we put in? We know there are 65 students. We know that 29 play volleyball and 26 play basketball, and 31 students do not play either. So how do we do this problem? What's the problem? I don't know. The problem is to show the students. Problem is we got to have 65 students within this box. 29 of whom play volleyball, 26 of whom play basketball, and 31 of whom don't play either sport. So could we just say, oh, okay, we're just going to put 29 in there, and 26 in here, and 31 there, right? Because there's 29 that play volleyball. So how many is that in total? What's 29 plus 26 plus 31? Like 86. Okay, well, there's a problem there, right? We don't have 86 students. We have 65 students. So which of these numbers should we leave and which should we get rid of? We're going to leave the 31, right? We know there are 31 outside the circle, right? They don't do either. Okay, so 31 students. Now, how many are there in total? There are 65. And we have taken care of 31 of them, so how many students do we have left to account for? We've got 34 students left to account for. Okay, so that's number one. That's the first thing we did, right? So the first thing we did is we put the 31 students who do not play either basketball or volleyball into the box. And then we said, okay, so that leaves me 34 students left, but I have what? 23 and 26. So we've got 23 and 26. I think I wrote a 29 in there before. And 26. So we have 49 students, right? We have people playing basketball. We have a total of 49 students who play volleyball or basketball, and we've only got 34 students left to account for. So what does that mean? Yeah, some play more than one. So how many play more than one sport? Okay, well, we got 49, but there's only 34 students, so that means there are 15 students who play both sports. And so they go in the overlap, right? So they're inside the volleyball circle, but they are also inside the basketball circle, right? Now, okay, we know, so that there are a total of 23 who play volleyball, how many do I have inside the volleyball circle right now? 15. So how many play only volleyball? 8. So now inside the volleyball circle we have 23 students, right? 8 of whom only play volleyball, 15 of whom play both volleyball and basketball. How many do I have in the basketball circle right now? I have 15, so how many only play basketball? 11. So if you look at it now, we have 26 students inside the red circle, right, who play basketball. We have 23 students inside the blue circle who play volleyball. Of those, 8 play only volleyball. 11 play only basketball. If we add up 8 plus 15, we get 23. Plus 11 gives us 34. Plus 31 gives us 65. Right? So now we have all 65 students inside the box. We only have 65 students because there are only 65 grade 12 students in this particular school. So that's how we fill in these diagrams, right? Start off. We can't use the 23 and the 26 right away because I don't know how these guys split up, right? Like some play only volleyball and some play both. Okay, so that's the idea. Okay, don't worry about that. Summary, big lesson, right? Sets that are not disjoint share common elements, right? So if there were no 2 sport students, then we would have had 2 separate circles, right? You only play basketball or only volleyball. You can't do both. Okay, now we know you can because the seasons don't overlap. Each area of a Venn diagram represents something different. When 2 non-disjoint sets are represented in a Venn diagram, you can count the elements in both sets by counting the elements in each region of the diagram just once, right? So that's what we did here, right? We just counted each region. 8 play only volleyball. 11 play only basketball. 15 play both volleyball and basketball. And 31 play neither. Total of 65 students. If we look here, these are the elements in set A and set B, right? So they belong to both sets. This area here is only set A, but not set B. Okay, so we don't have the overlap. So just the red. Just the blue is elements that are in set B, but not in set A. And then the kind of, I guess this should be purplish, is elements in both set A and set B. And in the gray, it's the elements that are in the universal set, but not in set A or set B, right? That it's in neither set. Each element in a universal set appears only once in a Venn diagram. If an element occurs in more than one set, it's placed in the area of the Venn diagram where the sets overlap. Okay, that's the lesson. Now we're going to do 5 questions. Further your understanding, consider the following sets. We have the universal set, consists of the numbers 2, 3, 4, 6, 8, 9, 10, 12, 14, 15. We have set A, 3, 6, 9, 12, 15, which appears to be multiples of 3. We have set B, 2, 4, 6, 8, 10, 12, 14, which appears to be multiples of 2, right? Or this is even numbers, this is the odd numbers. Illustrate these sets using a Venn diagram. Oh no, we can't say even and odd because that's even. So it's multiples of 3, multiples of 2. Okay, so draw a box. 2 circles that overlap. This is A, this is B, this is U. Okay, where do we start? What's the first number that I'm going to write, and where am I going to write it? Well, in a sense, it doesn't really matter, right? But let's go with the overlap. So what numbers are in the overlap in both A and B? 6 and 12. 6 and 12. And we fill in only set A, right? What numbers go in only set A? 3, 9, 15. What numbers go in only set B? 4, 8, and 14. What elements are in neither A nor B? Are there any that are in U but not in A or B? No. So then B could be written as, how else could we write B? A prime, right? Not A. How else could we write A? B prime, right? Not B. So they're complementary sets, right? You're either in A or B. You can't, oh sorry, that's not true. You're not either, no, so forget that A prime, B prime. Never mind, scratch that, rewind. Back up the bus. Illustrate these sets, use K. Done. Determine the number of elements in set A. How many elements are there in set A? You do it from the diagram, you just count. There are 5 elements in set A. How many are in set A but not in set B? So the ones that are only in A. 3. How many elements are in set B? 7. How many are in set B but not in set A? Okay, so there's 2 ways to say that, right? We could say in set B but not in set A, or we could say only in set B, right? Only B. So these are the guys that are only B, not in an overlap, right? These are the guys that are only A. These are the guys that are in A. These are the guys that are in B. How many are in set A and set B? Okay, and set A and B is 2, right? So they're in both sets. How many in set A or set B? Set A or set B? How many? Say, no. How many are in U? 10. Okay, so in set A or, there's nothing outside of set A or set B, right? There's no 31 students who don't do either, right? You're either in A or B or you're in both. So how many are in A or B? 10. Right, all 10 of the elements. So when you see in set A or set B, it's in A or B or both, right? And really all you're just going to do is just go in here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? That's the easy way to do the or. A or B. How many are in A prime? One, two, three, four, five. 5. Right? A prime is not the same as B. We figured out after we didn't figure it out. Number 2. There are 38 students in a grade 12 class. The number of students in the drama club and the band are illustrated in the Venn diagram. Use the diagram to answer the following questions. How many students are in both the drama club and the band? 8. How many students are in drama but not in the band? 11. How many students are in the band but not in drama? How many students are in the drama club? 19. How many are in the band? 14. How many students are in at least one of drama or band? 25. Add the 3 together, right? Drama or. The or is you add up each of the numbers, so 25. How many students are in neither drama nor the band? Okay, so 13. How do you know it's 13? So people looking away. Where did 13 come from? Because there are 38 students in total, right? We've accounted for 25 of them, so there are 13. Okay, any questions? Anna surveyed 45 students about their favorite sports. She recorded her results. We got hockey, we got soccer, and neither hockey nor soccer. Here's what you do. You get a problem like this, you draw a Venn diagram. You draw 2 overlapping circles because, and if it turns out that there's nobody in the overlap, you can just put a 0 in there, right? Or just not write anything in this little overlap space. Okay. So even if they are disjoint sets, right, if they share no common elements and you draw them as overlapping, you would come to realize there's nothing in here, right? So, oh, really I should have drawn them as disjoint because they don't share any common outcomes. All right, what's the first number we write and where do we write it? Put 16 where? Outside the circles. So this is the universal set, right? Universal set consists of 45 students. We have dealt with 16 of them. How many do we have left to deal with? 29 students. Okay, we've got 29 students. But if we look at hockey and soccer, how many students are there to do there with what? We had 34 students, right? But we only have room to put 29 of them. So what do? 5 are in the middle. 5 do both, right? So now we take the 34 students that are remaining to be placed in the diagram, but we subtract the fact that we only have 29 students left, giving us 5, and that goes in the overlap. Okay, so there are 5 students who do both. So how many do only hockey? And how many do only soccer? And if you add these 4 numbers together, what do you get? Full number, 45. Okay, so that's a way for you to check, right? You want to check this, you okay, 15, 20, 29, you can use your calculator, right? I got 45. Good, that matches what I'm supposed to be doing, 45 students, right? If I get more than 45 in here, then something's been done wrong. Okay, so here's your problem. You just look at this, you have no idea how that was filled in. Right? So you need to know, right? We started with, here's the order we went in, right? We did this, that was number 1. We went up here. The second thing we did was figure out the 29. The third thing we did was figure out this. We put this in, and then we did this, and then we did this, right? And that's the order that it goes in. There are 55 guests at a ski resort in British Columbia. Of these guests, 25 plan to go skiing and 32 plan to go snowboarding, and there are 9 guests who do not plan to ski or snowboard. How many guests plan blah blah? So we're going to answer any questions to deal with this. We're going to start off with the Venn diagram. Okay? You do not want to be doing formulas to do this stuff, right? Because it's just too much. So we just say ski and snowboard, and we got the universal set, and what's the first number, and where do I write it? 9. Where do I put it? Outside. Okay, so how many people do I have to deal with now? We got 55 minus 9, right? I need 55 in the box in total, and I've already got 9 of them. So what does that leave me? 46. Yeah, so there are 46 people left to deal with. Now, if I just go and put 25 and 32 in there, I will have put how many people? 57, right? So I can't put 57 people, so what do? Where's the 11 go? In the middle, right? So 11 are going to do both. How many are only going to ski? And how many are only going to snowboard? Okay. And if we add those up, it should come up to 55, right? Okay? That's how you do it. Now, if you want to do it wrong, let's look at number 5. Ryan drew the following Venn diagram incorrectly. There are 25 items in the universal set. What's the problem right here? He's got 27 items in the universal set. That's a problem. And 4 items that are not in set A or B. Determine the number in A and B, the number, oh, we never answered this, right? How many guests plan to ski and snowboard? So ski and snowboard is 11. How many guests only ski? 14. Only snowboard? 21. Okay, 25 items, so what do we got to do? The 25 items in universal set and 4 items that are not in A or B. So let's say that Ryan was right, and there are 23 people, so there are 13 who do A and 10 who do B, but let's say what he missed was the fact that there's supposed to be some in the middle there, right? So, what is the number that's in A and the intersection in B? What's that going to add up to? The number, so we're going to have three numbers in those circles. What are they going to add up to? 21. What do they add up to right now? 23. So how many belong in both? 2. So then you should change this to, and this to 8. Right? So now he has 13 in A. And now he has 10 in B. Okay? But he's got 11 and 2 is 13, 21, 25. Okay. So he's got the right number. I had the idea, right? I need 13 in A, but it's not 13 who are doing only A. There are 2 who are doing both A and B, 11 who are doing only A, giving me 13. So the number in A is 13. But the number in A only is 11. The number in A and B is 2. The number in B only is 8. And the number in B is 10. So that's how we're going to handle that one. And that's that, right? All right, 1.2, done. 1.3.
Woo!
Intersection and union. If you don't do any of these, you're not going to be able to do them when it comes to test time, right? You just sit there and go, well, I know there's supposed to be numbers here, but I have no idea what they are. And maybe you'll luck into it, and maybe you won't. Okay, understand, represent the intersection union of two sets. So first, you can ooh and ah, baby raccoon, how cute. Jackie is a zookeeper. She's responsible for feeding any baby animal that cannot be fed by its mother. She needs to feed a baby raccoon every 2 hours and a baby lemur every 3 hours. She uses the 24-hour clock to plan their feeding. Right? It just means she's going to count from 0 to 24. She starts to feed the raccoon at 0200, which is 2 a.m., and the lemur at 0300, which is 3 a.m. So, at what times will Jackie need help to feed the raccoon and the lemur? So, when does she have to feed both of them? So, to do this, let set T represent all the hourly times from 1 to 2400. Okay, so then T is going to equal the set one through 24, right? 1, 2, 3, 4, 5, etc. Let R represent the times for every 2 hours up to 24. So R is equal to 2, 4, 6, and so on, and then 22, 24. And L represent every 3 hours. So 3, 6, 9, and 21, 24. Describe the universal set T and the subsets R and L in set notation. Okay, or there they are there. List the elements in each subset. Okay, kind of almost did that. I guess we should just get a little more. So, what do we got? L or R? R is equal to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. L, 3, 6, 9, 15, 18, 21, 24. Represent the sets T, R, and L using a Venn diagram. Place the feeding times in the correct... Okay, so L, there's no way it's going to be big enough. No way that's big enough. Let's go down here. Okay, there's L, there's R, there's U. Okay, what goes in the intersection? Where do they overlap? Okay, 6, 12, 18, and 24. 6, 12, 18, 24. Okay, let's go back, make sure we didn't miss anything. We got 6, got 12. Basically, we're just looking through here and we're looking for the even numbers, right? Because these guys are even. And these guys are multiples of 3. There are some multiples of 3 which are also even. That's what we're looking for, so we've got those. Okay, so inside R, I now need every other even number. So 2, 4, got 6, 8, 10, got 12, 14, 16, got 18, 20, 22, got 24. Inside L, I need all the odd ones. Or, sorry, every 3 hours. So 3, 6, got it. 9, 12, got it. 15, 18, we've already got. 21, and then 24. Okay? When doesn't she have to feed them? Well, doesn't have to feed them at 1. Okay, we got 2, 3, 4. She doesn't have to feed them at 5. We got 6. She doesn't have to feed them at 7. We got 8. Actually, any even number we already have. So it's only going to be odd numbers that aren't in here. Okay, so 9, no. So we got 11, 13, 17, 19, and 23. Okay, so here I've listed all the elements, right? So everything in here. So I should have the numbers 1 through 24. Each of them should only be written once, right? I shouldn't have like a 6 in here, 6 here, and a 6 here, 6 there, whatever, right? I shouldn't have any of these guys. Nothing that's inside any of the circles should be down here, right? I should have the 24 numbers. Okay, so now we can go answer questions about it. Look at that. List the elements in the intersection. Okay, definition. Intersection. The set of elements that are common to 2 or more sets. In set notation, A, intersect. It's an upside down U. It's read as intersect. Okay, A intersect B denotes the intersection of sets A and B. So you have to know this. Well, or do you? Where does it say on the formula? Formula sheet has an upside down U and then next to it the word intersection. Okay. So you don't have to know that the upside down U is intersection, but you have to know the intersection is the overlap, right? The intersection of sets A and B. So for example, if A is 1, 2, 3 and B is 3, 4, 5, then A intersect B is 3. Okay, so that's the definition of intersection. List the elements in the set R and the set L and R intersect L. So in R, we have 3, 6, 9, 12, 15, 18, 21, and 24. In R, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, blah, blah, blah. And in R intersect L, we have 6, 12, 18, 24. Okay, so R intersect L is 6, 12, 18, and 24. List the elements in R slash L. This slash means minus. So this is set R, but take away anything that's in L. Now another way to say this is to say only in set R. Okay? So you're not going to see this on the diploma. They're not going to give you R slash L, right? R minus L. In the book you'll see it. Might throw it on the quiz. You'll see it. But what they will do, instead of saying that, they will say, list the elements that are only in set R. Okay, so R minus L is only R. So what's only in R? Two, 4, 8. Okay, so that's only R, right? List the elements in L slash R. Okay, it's just 3, 9, 15, and 21. 3. Now to answer any of these questions, you want to draw a Venn diagram. Okay, it's the easiest way to do it, right? You list everything out there. Everything's only in there once. You can answer any of the questions by looking at it and figuring it out. Okay? You don't want to use, they're going to show you some fancy formulas in the book, right? We don't want to get into fancy formulas and stuff like that, right? Now, we will sometimes use them, and like I told you yesterday, there's some formulas in here that say P. These are probability formulas, right? It's going to be chapter 3, we're going to do probability. You can use any of them with a little n instead of a P. Little n would be the number of, right? So if I say, this says, number in A intersect B. Okay. Now, when we've drawn this, we're just going to count. So you're not going to use any formulas for counting, right? The number in L intersect R is 1, 2, 3, 4. The number in L is 1, 2, 3, 4, 5, 6, 7, 8. The number in R is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? You say, how many times does she have to feed the raccoon? 12. How many times does she have to feed the lemur? 8. How many times does she have to feed them both? 4. This is when she's going to need help. You need somebody to come in and help at 6, 12, 18, and 24. Right? I need some help. We got 2 animals. We got to feed them at the same time. It's kind of tough to do. So, and how many times does she not have to feed them? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 times in which she does not have to feed them. Okay, communication. So here's some definitions. Don't ask you often, do I? How many times do I say put the phone away? So here's the deal I'm going to make you. Either you put it away, or from this day forward, you will walk in here, place it in the drawer at the beginning of class, and pick it up at the end of class. So I want it away that is not visible. Okay? Make it invisible, make it go away. If it comes out to play between now and when I'm done, then it will never be seen in this room again. Understood? Okay? I don't do that often, but this is serious. In set notation, A intersect B is read as the intersection of A and B. It denotes the elements that are common to A and B. It's the region the two sets overlap. Okay, right here we have Beaver playing a guitar, and here we have a duck on the keyboard. And so, what do we have? We've got a keytar and an animal which has a bill like the duck, and there's a mammal, right? Duck-billed platypus. Yeah. Platypus playing the keytar. So that's the overlap of those two sets, right? What's in common, right? Anything inside blue is guitar-like or whatever, and anything inside, and so on. A union B. So this is how you remember union. It looks like a U. Okay? It's not really the letter U. It just looks like a U. Is read as the union of A and B. It denotes all elements that belong to at least one of A or B. So it's in A or B or both. To count it, you just add up the 3 numbers, right? That's the easiest way to do this. Draw the diagram, put everything in there, and either we've written the number of, right? I mean, when we did the skiers, we didn't put down their names. We just said there are this many who only ski. So we may have the numbers, or in this case, we had the actual times in there, right? Like these, we didn't write down there are 4 of these and 4 of these. We didn't put down the number of elements, we listed the elements. Okay? Now you could count them. So you say, well, there's 4 there and 4 there and whatever there, so it's 4 plus 4, and so on. So that's the union. It's in A or B or both. Okay, so only A, only B, both A and B. Right? This is A and B. Another way to read intersection. Another way to read this is A and B. And another way to read this is A or B. Okay, so the intersection is and. It's in A and B. And the union is or. It's in A or B or both. Okay, so when we use the word or, it's the inclusive meaning of or. Right, it means it could be one thing or the other thing or both. So if I say I have a nickel or a quarter in my pocket, that statement is true as long as I have one of those or both of them. Okay, so inclusive meaning of the word or. A/B is read as A minus B. Not on the formula sheet, won't be on the diploma written like this, but another way to say this is A/B is only A. Okay, denotes a set of elements that are in set A but not in set B. It is the red region in each diagram. So A minus B when B is a subset of A. So B is part of A, we just take that away, right? It's colored blue. A only is the red. If they're disjoint sets, it doesn't really matter, right? There's no overlap, so A is just A. And if they are sets that do overlap, then we get rid of the intersection, right? So it's only A. So A minus B, that's the notation. You see it in the book, written A minus B. Might see it on the test that way. It means only A. Set of times that belong to either feeding schedule of every 2 hours or every 3 hours or R union L. So the union of those, list the elements in the union. Okay, now when you do that, you only list each element once. Okay, you don't write 6 down twice because it's in R and it's in L. Right? So R union L is 2, 3, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 22, and 24. Okay, so that would be the number of times. I'm not going to list the 6 twice because it's in A and it's in B, right? I'm not going to list the 12 twice. Okay, just list them once. List the elements in R, U, L prime. So that's every other number from 1 to 24 that's not in here. I'm not going to list them, right? But it's just 1. I think I already listed them. Right? I mean, it's the ones I wrote in the bottom that were just in U. Include these elements in your Venn diagram. Yeah, been there, done that. Complete the statement with and or or. Okay, I already defined that for you. So the set R intersect L consists of the elements in set R. And then therefore by process of elimination. So it used to be, if you look at an old Applied Math 30 formula sheet, the formulas that you get where it shows union and intersection, they actually use the words and or. Okay. So that's why I'll often use them and if I'm saying, if I'm looking at intersection, I'm thinking and. If I'm looking at union, just say union is uniting, it's putting them all together, it's in one or the other or both. Reflecting, let's not reflect. I mean, this just a formula, right? We'll get into those. All right, cards. How many of you are familiar with a deck of cards? How many of you are not familiar with a deck of cards? All right, whether you are or not. In your book, this is a deck of cards. So a deck of cards has 4 suits. These suits are clubs, spades, hearts, and diamonds. 2 of these suits are red, and 2 of them are black. There are 13. These are called the ranks. Oh, why did I move that? Dang. I've moved that. Let's see if we can slide this back. Ranks. Okay. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king are known as the ranks. These guys are also known as face cards. So there are a total of how many cards in a deck of cards? 52. How many weeks in a year? Coincidence? Probably.
Oh,
I just want to like whack her on the side of the head or something, just lightly. So, okay, there are 52 cards in a deck. There are 13 cards in each suit. There are 4 suits. 4 times 13 is 52. There are 3 face cards in each suit. 3 times 4 is 12. So there are a total of 12 face cards. Okay. There are 26 black cards, clubs and spades. There are 26 red cards. Right? So you need to be familiar with these because you're going to get questions on card deck. Probably not on the diploma, but I for sure will ask you questions on cards. Also, when we go to study the probability of poker hands, which of course is some useful math, right? Like you're watching late night sports and all of a sudden it's all poker for some reason. I guess that's a sport. But every time they show stuff, they're always showing the odds, right? Say, so this guy now has a 95% chance of winning. Why is that, right? So we'll figure that out. Okay, why are the hands ranked the way they are, right? Why is 3 of a kind better than 2 pair? Why is a flush better than a straight? That's true. And so on, right? And there's a reason for that. And it's all based on math, and that's all based on probability. And in order to do probability, you need to understand sets. In order to do probability, you need to understand counting theory. That's the next unit. In order to count, you got to understand sets, right? So we can talk about sets of things. All right, we got all these cards. Describe set C, S, H, and D in the universal set U. I think we did that. Determine the number. We did that, right? So there's 13 of each of these guys. Describe the union of spade and hearts. So what's the union of spade and hearts? What's union mean? Put them together. So it's just all of these, right? How many cards are spades in the union of spades? 26, right? It's 13 in each suit. Okay, so there are 26 cards, right? The number, so this is the number S union, right? Now, another way we could say that is the number in S or H, right? It's a spade or it's a heart, right? There are 26, right? It's 13 in each. Describe the intersection of S and H. How many are both spades and hearts? So S intersect H. So another way to say it is the number in S and H. So how many cards are both a spade?
Yeah, there's supposed to be one big one. Most Kleenex boxes is big. You just get little ones.
So how many are in the intersection? How many cards are both a spade and a heart? 0, right? There are none. Right? It's either a spade or it's a heart. It can't be both. Right? And that one's 26. So spade and heart would be disjoint sets. Right? As a matter of fact, if we drew a box and put spades and hearts and clubs and diamonds, they would all be separate circles. There's no overlap. Right? If that's the way that we're going to classify them. If we're classifying them by saying, hey, let's put face cards in the middle, right? Or let's do something about face cards, then there's overlap, right? Because there's face cards that belong to both. So in this case, you. Oh, what was the question? Or those were the questions. Yeah, that's the solution. Fine. You can read her solution if you want. I don't care about her solution. Right? That's basically what we're going to do, right? We kind of look at the examples and we'll do it, and then you can look and say, but wait, that's totally wrong. They said this. Then I'll come up with a different explanation. All right, the athletics department of a large high school offers 16 different sports. Badminton, basketball, cross country, blah, 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 and so on, right? Determine the number of sports that require the following types of equipment. A ball and an implement, such as a stick, club, or racket. Okay, let's just go put a little a beside. So let's go through all of these guys and we'll decide if it belongs in little a, little b, little c, little d, or little e. Okay, so where does badminton, so we got A, ball and an implement such as a stick, a club, or a racket. B, only a ball. C, an implement but not a ball. D, either a ball or an implement. And E, neither a ball nor an implement. Okay, badminton, what does that require? Requires a racket. So is that A? Not a ball. Okay, so not a ball. An implement but not a ball, right? So that's C. Okay, does it belong to anything else? Either a ball or an implement? So does badminton use either a ball or a racket? Yeah. Does it use neither a ball nor an implement? No. Right? I mean, you can't be in both D and E, right? I mean, either you use one of them or you don't. Basketball, what's that? So B, only a ball, and what else? So anything that's in A, B, or C is also going to be somewhere in D and E, right? So every time we write one of these, yeah, have fun. Anytime we write either A, B, or C, we also have to put D or E with it. So which goes with that, D or E? D. Cross-country running. Okay, now in this case, actually, we don't have to write A, B, or C. It's just E, right? Neither of. So I kind of like curling. Does it have a ball and an implement? It's not a ball. Is it only a ball? It's not a ball. Does it have an implement but not a ball? Yes. And what else are we going to say about it? D. Football. So only a ball and either a ball or an implement. Golf. A, right? A ball and an implement. Yeah. Sure. Don't take your phone. Good. Golf. A ball and an implement, and then what else? Either a ball or an implement. Right? Hockey. An implement but not a ball. C and D. Lacrosse. Both, right? It's got a ball and an implement. Rugby. B and D. Rugby's like basketball, right? You just have a ball. Cross-country skiing. So you need an implement, we'll say that either the skis or the whatever. So you get an implement but not a ball, and so what is that? C and D. Soccer. B and D, right? So if you're writing B, you're writing D, right? Softball. That's like baseball, only with a softball. Tennis. Leave this one for you, you should know this. Tennis.
Oh, no, yeah.
And you actually play this, right?
No, A and D.
At a relatively high level, as I understand it. Ultimate.
Oh, that's Frisbee.
Yeah.
It's the Frisbee and
Frisbee is an implement. Volleyball. B and D. Wrestling. E. Neither ball nor. Okay. So once you've categorized all of these, then so if we look at how did Terry define them? U, sports offered by the athletic departments. B, sports that use a ball and sports that use an implement. Okay, but we've got overlap, right? So you have to overlap these, right? Because he's listed, when he's listed the ball sports and he's listed, some of them fall in both of these categories. As far as the numbers go, the number in the intersection, right? So once you've done this, the number, you don't have to worry about formulas and stuff, right? You just go in here and you just count. 1, 2, 3, 4, right? How many use neither ball? 1, 2, 3, 4, right? It's neither ball. I don't know. Cross-country skiing, I think there's an implement in there. So we do differ a bit on how we categorize them. So they did a little bit differently. Here's their answer to all the stuff, leading to determining number of elements in a set by reasoning. This is pretty much what you're going to use, reasoning. We don't want to do formulas, right? You want to stay away from formulas. So you just reason it out. So Jamal surveyed 34 people at his gym. He learned 16 do weight training, 21 do cardio, and 6 train fewer. So what's the first number we write? 6. Okay, leaving us with how many? 34 minus 6 is 28, but we've got 37. 28 minus 37 is 9. So the weights, only 7. Cardio, only 14. These should add up to 34. And they add up to 36. 20. Okay, what did I do wrong? 16. 12 instead of 4. Oh, 21. Yeah, nice. Oh, that was good. Okay, these should add up to whatever, 34. So we got 16 and 18 is 34. Thank you. Right, that's the reasoning, right? And that's just the same reasons we've done before. So I didn't write it all down, but then that they would have written that down in the thing there, right? That's how you want to do these problems. Okay? That was good. You want to do that. Okay, let's fix that later. Correcting errors in Venn diagrams. You can read through that yourself. And there's the solutions that you can read through, right? Key ideas. So here's the key ideas. You can read them yourself as well, right? It's on page 31. Okay, here's all these formulas. Do you want to use these formulas? No. Nobody in their right mind would want to use these formulas, right? What you want to do is this. You want to draw the Venn diagrams, nice little overlaps. If there's no overlap, that means the sets are disjoint. Then you draw them separately. Okay, this just talks about union of two sets. So the union, if there's overlap, and the union, if there is no overlap. And then it talks about the intersection. And if this intersection is the empty set, right? Which they are going to denote by writing this. Okay, that's the symbol, but it's on your formula sheet. So if you're saying, what's a 0 with a slash through it, right? Look on the formula sheet, there it is. Empty set. Okay, so that's that for 1, 2, and